This is lesson 6.5, interpreting quadratic equation roots, in other words, the discriminant. So our learning goals for this lesson are firstly to be able to determine the number of roots, and by roots we mean zeros, x-intercepts, solutions, for example. That's all we mean there. Of a quadratic equation by referring to the graph and equation. So can you look at a graph, can you look at an equation and figure out how many zeros or roots or x-intercepts there are? And we've already done examples of that before. You could factor, you could use your quadratic formula that we saw in one of the lessons. You could take a look at the graph and see where the parabola hits the the x-axis. So those are all ways to do that, and we'll see some more examples as we move on. Our primary focus in this lesson, though, our primary learning goal, is to be able to calculate and describe the results of the discriminant. So that there is probably a new word for most of us, the result of the discriminant. So we're going to take a look at what that means in the next few examples here. So here we have our discriminant. The discriminant is the part of the quadratic formula that is under the radical, meaning under the square root sign. So what does that mean? Let's get our pen tool ready to go here. So the discriminant part is this part here, the b squared minus 4ac. That's the discriminant. And so you can actually use the discriminant to figure out how many zeros or solutions that you have, how many real roots that you have. So that's a key term there, real roots. So we saw in one of the lessons that, for example, you could have situations where you might have parabola hit the x-axis here and here. So that's two real roots, we call it. We'd say that it actually has zeros on the x-axis. Sometimes we saw that you could have just the vertex hitting the x-axis, and so that would be one real root or real zero. But then we also saw that in some cases it doesn't actually hit the real axis, the x-axis, so it doesn't really have real roots. We say there are 0 real roots. In grade 11 you kind of learn what that means in terms of real roots, but right now we say that this one would have 0 real roots. So how can we figure that out using this discriminant feature that we just described over here? Well, the first thing is, if your discriminant, meaning b squared minus 4ac, is larger than 0, what that means is that you have two real roots. So if discriminant, I'm going to call that d, is larger than 0, then what that means is you have two real roots. If your discriminant, b squared minus 4ac, is equal to 0, so if d is equal to 0, then what that means is you have one real root. So basically, if d is larger than 0, you have a situation like this over here. So let's call this situation A. Situation A. If d discriminant is equal to 0, then you have a situation, so let's call this situation B. This is situation B over here. And if your real root is less than 0, then, so d, sorry, if your, I shouldn't say real root, if your discriminant is less than 0, so in other words negative, then what that's going to mean is that you have 0 real roots. So that would be situation C, which you can see over here. And if you think about it, that makes sense, because if you have a b squared minus 4ac that's less than 0, that means you have a square root of a negative number. And for now, we know that that's not possible. So that's why you would have 0 real roots in that case there. So let's go and take a look at the discriminant in a bit more detail, just to see what the graphs would look like as we described above. So here we have the b squared minus 4ac, the discriminant, being larger than 0. And remember, when that's the case, we have 2 roots. So it could be a situation like this, for example. Whoops, it's a bad parabola. Or a situation like this, for example. So our real roots are actually on the x-axis, like this here, or this one has there and there. If the discriminant is negative or less than 0, you're dealing with a situation like this, where the parabola basically will not hit the x-axis at all. So its roots are not real roots. You'll notice this one here opens from the top and just keeps going up, so it's not going to hit the x-axis. And this one here opens from the bottom and keeps going down, so it's not going to hit the x-axis. So you can see the vertex, for example, is above the x-axis here. Vertex is below the x-axis here, and it keeps going down. Over here, it keeps going up that way, so it won't hit the x-axis. And then, of course, like I said, if your discriminant is equal to 0, then that means you have 1 real root, and that's essentially where the vertex is on the x-axis. So your real root would be here, or you can have a situation like this. These are just some specific examples. They could be in other quadrants as well, but your real root would be there as well. So again, this is the part that's under the square root area. That's the discriminant. So this part here, b squared minus 4ac, AC, this part here, b squared minus 4ac, that is a discriminant. Again, if it's negative, well, you can't do negative of a square root of a negative number, so that's why you will have no real roots. If it's equal to 0, well, we'll take a look at why that means only 1 root. And if it's larger than 0, we'll take a look at why it means it's equal to 2 roots. So let's go do some examples together. So let's bring the examples back up here. Oops. Okay, so we're going to try this example out here where we want to determine the number of roots without solving, specifically, without solving. So what that means is we want you to find the discriminant. So we know the discriminant is equal to b squared minus 4ac. And so our b is, let's just write down our information here. B is negative 3. Our a, I'll write a here actually. A is 4. And then c, so c here is 7. And so let's plug that in. So discriminant is equal to negative 3 squared minus 4 times 4 times 7. And so that would be discriminant is equal to 9 minus 16 times 7, which is, our discriminant is equal to negative 103. So in this case, our discriminant is less than 0. That would mean you basically have a square root of a negative number, which is not possible at this point. Therefore, 0 real roots. 0 real roots or 0 real solutions. Let's try this example out over here. So before you solve for the discriminant, you need to make sure that before you determine the discriminant, you need to make sure that you distribute and put it into the standard form. That's extremely important, otherwise you won't get your a, b, and c values. So we distribute the x throughout here, so we get x squared plus 10x plus 25 is equal to 0. That's our first step. Let's write down our information. A is equal to 1, b is equal to 10, c is equal to 25. And then we can find the discriminant. So discriminant is equal to b squared minus 4ac. So discriminant is equal to 10 squared minus 4 times 1 times 25. And so discriminant is equal to 100 minus 4 times 25, which is 100. So our discriminant is equal to 0. Because our discriminant is equal to 0, what that means is that we have one real root. One real root. And if you think about it, it makes sense. Because if you do your quadratic equation, or your quadratic formula, let's say we're doing a quadratic formula for this here, you would get something like this. You would get your minus b, so minus 10, plus or minus square root of, well, 0, right? That's what we got for our discriminant, over 2a. 2a is 2 times 1, so over 2. Now, if you think about it, minus 10 plus 0 divided by 2 is the same thing as minus 10 minus 0 divided by 2. There's only one choice, really. You're not going to split off and do minus 10 minus 0 gives you a different answer, minus 10 plus 0 gives you a different answer. It's like this is not even here anymore. So really you're just doing minus 10 divided by 2 gives you minus 5 as your x. So when you have a 0 there, you only have one option really, just minus 10 over 2. If you had something more than 0 here, like 16, for example, so square root of 16 is 4, then you could do minus 10 minus 4 or minus 10 plus 4, and that's why you'd have two real roots in that situation there. So it all pertains or relates to that square root option and this quadratic formula here. So hopefully you have some background understanding of why that works that way. So we're going to start off question number 2 over here to see how we would approach it. You got to think a little bit. Determine whether the vertex of each parabola lies above, below, or on the x-axis. In other words, what we're asking you is, first of all, how is the parabola opening? In which direction? And also, how can you relate that to the discriminant? How can you relate that to the discriminant? So, first of all, what I want to do is I want to find the opening of the parabola. So the opening, we look at the a value. A in this case is 2. It's positive 2, so it opens up, opens from the top. Okay, so we have a situation like this. But we want to find out where this vertex is. Is the vertex above or below the x-axis? So if we draw out our axis here, so step 1, finding A. Step 2, is it above or below the x-axis? We need to find the discriminant for that. So we know our B is minus 4, our C is 1.5. So our discriminant is going to be equal to minus 4 squared minus 4 times 2 times 1.5. So that means our discriminant is going to be 16. And then we're going to have 4 times 2, so it's 8 times 1.5, 16 minus 12. Which is equal to 4. So our discriminant is larger than 0. What that means is there are two real roots. So we know that our vertex opens from the top and that there are two real roots. So what that means is that our vertex must be below the x-axis for the parabola to actually cross the x-axis on its way up. If it was above and it opened from the top, it wouldn't hit the x-axis. So based on the discriminant and based on the way that it opens up, we're able to conclude that the vertex lies below. So we'll do another example in the next video and conclude this one as well in the next video.